Hello and welcome to Polynomials 5.1 Function Composition. Okay, so today we are going to go back to functions, and it's gonna be very similar to the lessons you guys had back in the first quarter, where the picture on the bottom of the slide pretty much is the exact same picture that you saw, I think, when I started doing functions 1.1. Okay, so it's not like you're going crazy. You did actually see this picture before, where you're gonna have an input, and whatever you plug in, you're gonna do something to that number, and it's gonna jump out as a different number altogether. Okay, so when we say composition, though, we're gonna actually do this. We're gonna plug one function into another, or we're going to use two functions together to accomplish one mission or one goal. And the best way I can kind of compare this to the real world is if you're at like your part-time job, where you have like a time card that you swipe or you scan, and your system, it logs in what time you punched in, and you swipe or scan, and it keeps track of what time you punch out. And for the entire 2 weeks that you punch in and punch out, there's going to be a little function that the computer is going to do, and it's going to count up how many hours and minutes you worked. Then it's going to give that number to another function, which is going to say, okay, based on how many hours and minutes you worked, you're going to figure out how much you should get paid, because it's going to multiply it by a number or an hourly wage. And those two, I guess, processes working together gets you the amount of money you're going to get in your paycheck. I mean, there's other things too, like taxes and stuff like that. So those are functions as well. But to keep it simple, right, I just bring up that example every year. Okay, and that's kind of like what we're going to do. We're going to use multiple functions to arrive at a different answer altogether. So we're going to use, the answer from one function, use that number, and plug it into another function. Okay, and when they write it in math, though, here's how it's going to look. So am I in pencil? Yeah, I'm in pencil mode, or pen mode rather. So this is how it's going to look. Okay, so they mean the same thing. So sometimes you're going to see f parentheses g parentheses x, close, close. Yeah, or you're going to see f with that little dot that looks like a degree sign, but it's not really a degree sign because degree signs are a little bit higher. Yeah, so whenever I read this, I always just say fog, right? Because it looks like an O, a really, really tiny O. So fog of X. Okay, that's not how you're supposed to say it, but yeah, that's how some kids they go, oh yeah, I remember you talking about that before. Okay, but for me, I prefer this way of writing function composition. Okay, it seems more natural. It seems more, I guess, more similar to how we wrote functions in the past, with parentheses and no little degree symbols that look like the word fog. Okay, all right, so let's move on. Next slide. And this is what I told you before. We're going to plug in a number. It's going to be plugged into our first function, and the first function is going to do its thing. Then it's going to spit out an answer, and that answer is going to get plugged into a second function, and it's going to do its thing, and it's going to spit out an answer. Yeah, so sometimes you're going to have things where you have one number plugged into three separate functions. And that's perfectly fine too, because that's, like I said, that's kind of like what the real world is, right? You can't just plug in your number of hours you worked and expect you to get your full amount times by 15 or times by 12, right? Because there are taxes. And there's lots of different functions or formulas that help figure out how much taxes you're going to pay, like state taxes, federal taxes, federal income tax, right, or Medicaid tax, right, Medicare tax. So yeah, there's a lot of different type of functions that are going to be, I guess, part of the process called payroll. Okay, so let's get to our first problem. All right, so here's how you do this problem. Okay, so you have f of g of -1. So when you do this problem, right, the best advice is to go inside out. Okay, so look for your innermost function and work your way out. So my innermost function is g, and g, according to the pictures on the right side, is a table. So it says, plug in -1 into function g. So what number pops out of plugging in -1 into function g? So let's just write that on the side. So g of -1, when I look at my table, when I plug -1 into the function called g, here's what happens. I get -2 popping up. Okay, so g of -1 is known as -2. So here's what I do on this first blank. I'm going to rewrite the exact same function that I just had on the left side, except now I don't have g of -1 anymore because I plugged it into the function and it came out as -2. Okay, so g of -1 got replaced by -2. And I'm going to use that new number called -2 to plug into function f, which is my graph. So where is -2? So here's -2 for the x value. Then I'm going to go up from there to get my y value, and that's going to be my final answer for this problem. So my final answer, when I look for the y value for function f, right, because -2 is my x value. So when I look for his corresponding y value, it matches up with 3. Okay, so that might have got confusing, so just rewind and watch again. Okay, but I'm going to erase these dots on the graph and on the table because I need to use these exact same tables and graphs for problem number or problem B and C. So let me erase that. Okay, so let's do problem B. So like I said, I don't really like when they write the composition of functions in this way. So I'm going to change it to this instead. So h of g of 2. Okay, so let's figure out what g of 2 is first. So g of 2, so I'm going to look for my table, and I'm going to look for an x value of 2, and I'm going to see what his corresponding y value is. So it's going to be a 4. So when I rewrite this notation, I'm going to write h of 4, okay, because g of 2 got replaced with 4. And oh wow, there's a function h. Oh yeah, there is. It's right here. It's in the instructions. Oh, here it is. I was looking for like some kind of a picture. So it's actually a formula. Okay, so it says for the function called h, plug 4 into it. Yeah, so it says 2x plus 3. So I'm going to plug a 4 into that x. So it's going to basically be 2. Oops, why isn't it writing? 2 times 4 plus 3. So that makes 8 plus 3, which is 11. And there's my answer, 11. Okay, so I'm going to erase this circle on table G because I need this table for problem C. Okay, all right, so let's do problem C. All right, so let's do our innermost function, which is f of 1 rather. So f is my graph. So I got an x value of 1, which is right here. So what is the corresponding y value for x equals 1? The corresponding y value is, oh, it's 0. Okay, so f of 1 is 0. So when I rewrite this first blank, it's going to be g of h of 0. Okay, because f of 1 got replaced by 0. So 0 is going to take his spot. So I'm not going to erase g, I'm not going to erase h, I'm just going to erase f parentheses 1, and I'm going to replace it with 0. Okay, so next step, let's figure out what h of 0 is. So h of 0 means I plug it into my equation, so 2 times 0 plus 3. So that's going to be 0 plus 3, which is 3. So now I'm going to write this, so g of 3. Right, because h of 0 is known as 3, so I replace h of 0 with 3. So when you do function composition, you're just pretty much replacing things. Okay, you're replacing it with whatever you're told it became. So f of 1 became 0, so I replace it with 0. H of 0 got replaced with 3, so I put a 3 in that spot. Okay, and now I'm going to go to the table called G, and I'm going to look for my x value of 3. So here's my x value of 3 in my table called G. And who does he correspond to? He corresponds to a -3. And that's my final answer. Okay? Alright, so hopefully that made sense. You can rewind if you need to, but let's go on to the second problem. Okay, so now it's going to get a little more complicated because now we're going to plug one formula into another. Okay, and I don't like the way they wrote it this way. I mean, everybody has their preference. You guys might like it. I just don't prefer it. So I'm going to change it into f of g of x. Okay, so this basically says plug x into g. And you're going to be like, what do I do? Because it's not a number, right? Because normally in the previous problem, we actually plugged a number into g. Well, we don't have a number, but we do have these two equations, right? We do have these two equations. We have function f, we have function g, and watch what I do. So notice inside the parentheses, it says g of x. So watch what I do in my first step. I'm going to erase g of x, and I'm going to put what he is, which is x squared minus 4x plus 2. So here's where it's a little bit different. We're not plugging in a single number. We're plugging one formula into the other formula. So notice how g of x disappeared and it got replaced with x squared minus 4x plus 2. Okay, and here's where you're going to hate it now. So now I got to plug this entire formula, x squared minus 4x plus 2, I got to plug it into right there. I got to plug it in for that x. Because it says, right, plug this entire thing into function f. So you see that x for function f? This whole x squared minus 4x plus 2 is going to replace that single x that you see there. So watch what happens. Okay, so I'm going to have 2. And this is where I normally have the x. But I'm going to replace it with this whole mess of numbers. So x squared minus 4x plus 2 plus 1. So this is still 2x plus 1. It's just that the x is no longer x anymore. It's x squared minus 4x plus 2. Okay. Then when I simplify, I'm going to distribute my 2 to these three things. So I'm going to get 2x squared minus 8x plus 4 plus 1. And I'm going to combine like terms. And let's see, when I combine like terms, 2x squared stays the same because there's nobody else like him. Negative 8x stays the same because nobody matches with him either. And 4 and 1, they're going to become 5. And there's my final answer. Okay, so let's go on to problem B. Alright, so now it says plug f into g. Okay, so when I rewrite this problem, it's going to be g parentheses, and I'm not going to write f of x, I'm going to write what f of x is, which is 2x plus 1. And here's where you're going to hate it, because now we're going to go to function g, and everywhere I see an x in function g, I'm going to replace it with 2x plus 1. So watch this. I'm going to put a 2x plus 1 there, 2 times because it's squared. Then I'm going to put a 2x plus 1 right there, because there's an x there also. Okay, so it's not going to be as easy as letter A, because in letter A, function f only had a single x. In problem B, function g has a lot of x's. So I got to plug 2x plus 1 in a whole lot of places. And this first guy is going to get squared. So I'm going to write 2x plus 1 twice because it's squared. And then minus 4. And then I see an x again, so I got to write 2x plus 1. And then plus 2 at the end. So thankfully the last guy didn't have an x, thankfully. Okay, then I'm going to have to FOIL. Right, so 2x times 2x is 4x squared. 2x times 1 is 2x. All I'm doing is foiling it. 1 times 2x is 2x. And 1 times 1 is 1. Then I'm going to distribute the negative 4. So negative 4 times 2x is negative 8x. And negative 4 times 1 is negative 4. And then plus 2 at the very end. Okay, so now let's do like terms. So nobody matches with 4x squared, so he stays the same. I got 2x, 2x, negative 8x. So that's going to make negative 4x. Then I got 1, negative 4, and 2. So that makes negative 1. And you're done. Okay, I don't think there's any more problems. I think the next problem is homework. Let me just check. Okay, yeah, it is. So good luck with this assignment. It's probably a little easier than the video you guys just watched the other day for Polynomials 4.1, so hopefully it's a little bit easier. I kind of went fast, so if you guys need to rewind, by all means, rewind as many times as you need. Okay? Yeah, good luck on this assignment, and I will see you in class. Bye-bye.